in this video. Hello everybody and welcome to the 18th video on my channel, which is another Algebra 2 video with another video on the Exponentials and Logarithm series, which I'll explain in the lesson. But one more big favor, please make sure to like and subscribe for more awesome content just like this. Without further ado, let's go on to our answers to our previous questions. Number 1. Logarithm base 7 of x divided by y, first question. Number 2. The natural logarithm of 9. And number 3. Logarithm with the base of 4 of 51. Without further ado, let's go to the lesson. Today's lesson is a continued logarithm formula video where I am showing you some more logarithm formulas, and these are the two other logarithm formulas which are very essential to know. And without further ado, let's just get into them. Our first logarithm formula states that if I have the logarithm with the base of a, it's actually shown over there, so I don't need to show you. Logarithm with the base of a of a number b to the power of n, that's equal to n times the logarithm base a of b. An example of this is if I had logarithm base a, no, maybe not base a, why don't we do base 3 of 7 to the 5th. This is equal to 5 times the logarithm base 3 of 7. This is how the formula works. For our second formula, we have, this is called very famous. This is called the change of base formula. The change of base formula is if I want to convert a logarithm with another base into a natural logarithm. A lot of these applications are in higher mathematics because natural logarithms are way easier to work with once you get into more advanced fields like trigonometry, geometry, calculus, blah, 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 all that advanced stuff. So it's a handy formula to know, and even in practical situations when we're just using algebra. If I have logarithm base of a of a number b, I get that I can say that as natural logarithm of b divided by ln a, or natural logarithm of a. Without further ado, let's move on to the examples. Today we have 3 examples, and in all 3 of them I'll actually be stating what to do in order so you don't get confused, and I will do the same thing for the practice problems. For our first example, we have the logarithm base 5 of 7 cubed. As you can see, I want you to simplify it, or maybe you couldn't see it. Well, either way, I want you to simplify this, and I'm going to show you how to do it. Now, 7 cubed is kind of weird, and it's a little complicated. So what we can do is we can use the logarithm formula that states that if I have the logarithm base of a of 7, just b to the power of n, that's equal to n, which is 3, logarithm base a, logarithm base 5 of 7. For number 2, it's pretty much the same thing, except it's the exact opposite. We want to make sure that we get it all in one thing. The normal application of this is if let's say I have 5 logarithm base 7 of 9 plus logarithm base 7 of 65. What we want, now 7, sorry, not 5. What we want to do is we want to combine this to simplify this. By the way, this is not any of the problems, this is just an example. So a useful thing to do would be to convert this into this form. So we can actually simplify it with this to create an easier equation. That's one application. So if we do the actual problem, we will get something like logarithm base 2 of 3 to the power of 5. Or we can say logarithm base 2 of 243. You can do either one, both of them in my opinion, both of them are fine. And for a third example, we will have to do change of base. We'll have to change the base from this to the natural logarithm. This is simple. What we gotta do is we gotta have logarithm base 7, not logarithm base 7, my bad. It's the natural logarithm of 100 divided by the natural logarithm of 7. this is the answer to our third example, and I think it's time that we go on to the practice problem. Our three practice problems for today is number 1, logarithm base 9 of 3 to the power of 6. I want you to simplify this and make sure that it satisfies one end of the logarithm with the exponential formula. So what I want to do is basically convert it, instead of this 3 to the 6th, into something. I won't tell you what. Let's just represent this by some oval times logarithm base 9 of something else. I'm already giving you the logarithm base because that's basically what we want to do. For our second problem, the point is to do the exact opposite and convert it from this form to the form above. And for our third problem, we're going to be using change of base, which is a very useful formula, of course, and we want to change the base from this to, of course, nothing with the natural logarithm. Thank you so much for watching, and see you in the next one. Bye-bye.